Welcome back to Advent of Code Day 4 2021. Today we are working with the giant squid. We are playing bingo with it, and we have a more complex input than what we used to have. So as always, I'm just pasting the input in there. We are copy pasting the input reading code from day 3, and we need to modify that, and we dive into the fun stuff. So first of all, today we want to have this list of number, which is the list of number that are said in the bingo, and this is the bingo cards. So we want to split the cards. So now we cannot split just on a line return, but we need to split on a double line return. And I'm going to start by logging the lines right away, just to make sure we are doing something fine. Because today the input reading is going to be a bit more complex. Okay, so we are doing fine. Next up, I am just going to be mapping for each line. We're gonna say x.replace. We want to replace all the line return by nothing. We just want to remove the line returns, and I'm gonna show you what it's like. Oh, I think I should need to keep a space. Okay, so here we're gonna say line return and spaces. We want to replace that by just a space. Okay, and we're going to do the same with the comma. So basically, everything is just going to be like one big list of numbers. So I don't know, I think this is a bit of a hack, but basically we have something that looks good. I think we want to get rid of the space at the beginning of the end. That's looks like something that's going to be annoying, so we're going to trim. Okay, trim. And now we have just a list of number separated with spaces, so we can actually split on a simple space. I think that's it. So basically with that, we really focused on cleaning the input, cleaning the double spaces, the line returns, everything. And with that, we split a string that is composed of number and spaces and it just returns a list of numbers. However, here, as you can see, this is not numbers, this is strings. So we're going to be mapping that. Parse int y. This is fine. So this is fine. What we want to do, we need to do that const. We want the numbers and then the cards. And I believe if we do that, what I want to do here is to extract the first element of this big array, that we have this in the variable numbers, and then I want to have all the cards in the variable cards. So yes, that is working fine. We are using the spread operator from ES6. That's quite useful. Basically, it's just taking the head of an array, putting it in numbers, and taking the rest of the array, putting it in cards. So was a lot of input cleaning, but now we've got something that is kind of okay. We chose, actually I didn't really choose it, but we have the cards as a single array of integers instead of having a matrix, like a 2D array. And I think that's quite fine because we can do like a lot of operations on that. So that is it. I think what I would like to do to make this super clean and to like prepare for the next steps is to actually make a class here. So I'm not creating new classes very often, so I might do some weird things here. Constructor, we want the array, and we're going to say this dot where do we say the numbers? I don't like that. We said numbers here already, and here I'm using numbers again. So here we need to change this. Let me just take a second. There is numbers marked. Drawn. So we're gonna say that drawn numbers here. Drawn numbers. That makes a lot more sense. And here this is the card numbers. So that is looking fine, and this is gonna let's call everything numbers. So yeah, that's fine. So here we're gonna say cards equal cards dot map new card of X. Okay, so we're gonna put the class here. So I think I could have made that in like procedural aspect, but I really like having an object here because we might need to reuse the cards and we can store several things inside the card. So I think this is going to be a bit better. Oops. Assignment to constant variable. Oops. Okay, const. Okay, let's not use const. Let's just use let. Yeah, that's going to be fine. Okay, card with numbers. We are good here. I think we need to say something like marked or add drawn numbers, and here we need to do something to mark some numbers as drawn. So here we would like to keep, what do we want actually? Let's go back to the program statement. We want to keep the numbers that are drawn, and we want to keep the numbers that are not drawn. So what I'm thinking here is we're going to filter So the drawn numbers, we can also use a set. So yeah, there are several ways to do that. I'm just going to spend a second to think about that. Okay, so I've read this again. And one thing that's very important is that we need to take the first numbers, apply it to all grids, then take the second one, applying to all grid. And each time we apply a number, we need to check if one of all of the grids is full. And if we take the full puzzle input, I believe there's a ton of grids. So we can't every round like check for every grid, every line, and every column. I believe this is going to be too much. So I think we need to optimize that a little bit. What I'm thinking for now is we're going to be doing we're going to check if the number is in the array. We're going to take the position of the number, and we're going to check that it isn't marked already. I think there cannot be a number twice in there. So we don't need that. But so let's start with that, because I think explaining might not be the right move. So add marked number. We need to do this dot lines is it always a card that is 5 by 5? Yeah, I think we're going to say this is a 5 by 5. So just to make sure we don't need to change that in the future, const. Oh, actually, let's put it here. This that card size equal 5. So now we can say this dot card size, and we fill that with zeros. So we have, for each line, we know how many numbers are filled and how many numbers are not filled. I think that's gonna be it. So what we could do as well, we could say here, we're going to be doing this really fast. We want to do that really fast, so we're going to do that. So here we're going to say number to position, and we're going to create a map, and we're going to do a for n of these that numbers. We're going to say this that number to position dot add. How do you add something to map? Set. You set a key and a value. So here the key is going to be n, and the value is going to be line and column. So how do we know the line? Oh, actually the for is not going to be the right thing to do. We need to know the index. So it's going to be a I is that number, oops, numbers. So yeah, the for of is great, but you cannot have the index. So that's a downside of it. So here, the line is just n modulo this that card size, I believe. So basically, if we have one position 0, it's 0. Position 4, 5, let's say. Wait, 0, 1, 2, 3, 4. Position 4, this gives you 0. Position 5, it gives you 1. Yeah, so every time it's between, yeah, I think this is correct. And here the column, we need, wait, no, this is the column here that we are doing. And here this is math.floor n divided by this dot card size. So what I'm doing is I'm creating a map where each, when you say 15, it gives you the line and the column of this specific number. So we're going to try to run that again. Oh, this did not work. The map seems empty. Ah, why? Oh, here I missed dot length, which is of course really important. Okay, now we have something correct. Okay, but it's not displayed correctly. So say map, show map for of map this dot. So here I just want to display and debug this thing that get I. We're just gonna debug the first card. Let's see, is that correct? Oh, that's perfect. We have, for the first card, 22 is line 4, column. Okay, this is completely wrong. Okay, so we have a problem. I thought I just like went really fast on that. I'm gonna take a second to remember the right explanations here. Okay, I've been looking at this code for 5 minutes and I think I've just found the bug, which is very simple. Basically here I should be using the index I instead of the number itself. We want to store the number and use the index in the array here to find the line and the column. I'm going to try to run that again and see if that's correct. 22, okay, now we have something. Okay, okay, we're good now. So yeah, this was the right formula. It was just using the wrong number in it. Okay, so now we have, I think, all the ingredients in place. We have a map that gives you from a number the position. We have something that counts how many of the values have been ticked. So now I just need something here. I just need to do something here. So const position, we just need to do this dot number to position dot get number. If position, oh, let's do if not position, we return. So I believe, I'm not sure, let's do new map. Oh wait, I'm just checking something in the console down there, which is, what if we do get of test? Something that isn't in the map, yeah, it returns undefined, so we are good. This will just quote when the number that is drawn is not on the card, will return. And if the number that is drawn is on the card, then we do this dot lines of position dot line plus plus this dot columns of position dot column plus plus. And yes, that should be it. So now when we want to check if card is complete, oh actually let's do that. This dot is complete is false, and here we say if this dot lines is equal to this dot card size, or this dot columns is equal to this dot card size. Oh wait, of position dot line. So yeah, if the number of marked numbers in this line is the full array of or the number of columns in these columns, number of marked numbers in this column is the same as the card size, then this dot is complete equal true. So basically here we don't have to do any loop or anything. Every time we add a number, we do one operation per card, and we can check if the card is complete just using the is complete. So that should be it. Now we need to do the main part of the code. Now we've done a lot of things around it. Now we need to do the main thing, which is a for of drawn numbers. And for each number, we need to go through all the cards. So this is a nested for loop. Oops. Let's do for of, that should be good. Card of cards. And we do card dot add number, sorry, add marked number. Card dot add marked number, drawn. and we say if card.is complete. How can we break out of this? Haha. We're just going to do a function run. No, I don't like that. Let finished equal false. So here we say finished equal true, break. We want to break out of this loop, and here we say if finished, then break. Okay, here we need to store the winning card also. Let winning card equal card, and here we can finally log the winning card. Oops. Let's just make sure there is no problem. Okay, here we have the winning card with the first line that is complete. Let's see if this is correct. First line here is, oh yes, this is this card, and it is complete. So now we need to do something else, which is to find the sum of all unmarked numbers. I think because we have to do that with just one card, that should be very simple. Very simple. We just need to make sure that actually drawn. So here we're gonna put the numbers that are actually drawn. Actually drawn, that push drawn, because this is the full sequence, and here we want to know the numbers that have been actually drawn, not the full sequence. So now we just need to we're just gonna be, so this is, here we're just working with one card and a list of numbers, so we can do like a super nested for loop. That's not really a problem for performance. So here we need the winning cards. We need to take the what's the name of the variable? Numbers. Okay, let's do that. We're gonna filter these, and what do we want to say? We want to say if we want to return, actually let's not do like a full block. We want to say if if actually drawn includes n. In that case, we want to take the number that have not been drawn. So const, here this is the unmarked numbers. Unmarked numbers. And what do we want to do with that? We want to do the sum of this. So let's do the sum. I'm gonna log the sum of this and the sum of this. We're gonna, oops. Sum in JavaScript, you just do a reduce a plus b starting with 0, and we should have 188. Let's see if this is correct. This is correct. You multiply the sum by the number that was just called. Okay. So here we need to multiply that by the actually drawn dot slice minus 1, which is the last number of the array. Let's make sure this is correct. This is correct. So that was a bit long, but I think we've made it. Let's just make sure this is, so I'm taking the full input, running the code, submitting. feels good. So we have really clean code. I'm really happy about this one. Let's jump into part 2, which is quite small. Let's see that. Okay, this is really good that we focused on performance in the first part, because here we're basically going to have to run the full simulation and figure out which board will win last. So what we're going to start with is create a function for part 1. I think I'm going to do that in all the future things, because cards, let's say the cards, just, or I can underscore, because you say part 1 of cards. And the idea here is, because this is an object that has a state in it, I prefer to have like something cleaner like that. I'm actually going to do a copy paste. Even though I created a nice function, I'm going to do a copy paste with part 2, because it starts the same way, except here this is the simulation that we run to simulate the bingo, and we actually need to change things. So here we don't care about finished, because we want to run that. Actually, we do care about that. So we check if the card, oh my god, this is gonna be fun. Card, we're gonna check if card is complete. So one thing that I'm worried is I'm not sure all cards are gonna be filled. That's an assumption. So I'm gonna assume that all cards are filled. Actually, let's not do that. Let's say const last winning card. Let's do that. We're going to say here is complete. We're going to say last winning card is equal to card. But we're going to not break here. We're going to continue with all cards, except if so yeah, I'm gonna do that. So basically every turn we're gonna go through all the cards, and if they are not complete, we're gonna add the new marked number, and if this is complete, we're gonna set that his is finished here. We don't need that. Here we're gonna say remaining has incomplete cards equal false, has incomplete cards equal true, and if there isn't cards that are incomplete, then all cards have been completed and we need to break out of the simulation. And I think that sounds good. And here what we want is to use the last winning card. And actually we're going to store last winning number here. That should be fine. I think that should be fine. Last winning card, last winning number is equal to drawn. So basically here in these two variables we store the last winning card with the last winning number, So here we can say last winning card. We can compute the unmarked numbers of the last winning card, do the sum, and take the last winning number and multiply that with the last winning card. If we run that, actually let's try with a small example just to make sure we are not. You know what? Let's just try to run this number. So I think this should be fine. That's not the right number. That is not the right number. So we need to debug. I'm half happy about that. Okay, so this is the small input. If we have that, we should write here both these two things. 142. Let's check that. 148 should be the right answer, and then 13 is the correct answer. So there is something fishy about this 142. We're going to be logging the last winning card. One thing. So let's see, the last winning card after 13 is called and its middle column is completely marked. Middle column after 13. So this is the second card, second board. So here this column would be filled. And we have the middle column filled. That should be fine. So we have just one-off issue somewhere. I think we're gonna have to debug that. One thing I don't like is I don't have a good output here to debug the different steps. Okay, here we're gonna basically show the card at that point. Card.show. Show card. And we're gonna be doing a small function. Show card. Show map, I believe I've removed usage of show map, so we can just delete that. Show card, we need to go through each number. Actually, I need to display the card correctly. I'm gonna take a second for that. Okay, I think I've got an idea. So here we're gonna say const array. We want to just make a debug function to show the array in a square way. So we're gonna say for I below this dot card size I plus. Here we're gonna say array dot push, and we want this dot numbers slice between this I times this dot card size and this plus this dot card size. And then we want to display console log array, and we join with the line return. Let's do that. So there is too many printing already, too many printing happening here. There's a full card. being print. We don't want that to happen. Oh, show card. So show card needs to have like plus a line return to make sure we have like a bit of breathing room. Okay, so we have the actually I need to know how to highlight a specific, how to make a specific number bold in the terminal. Be really neat. And this here we want to join with a tab. Let's see that. Okay, we have our bingo card. I just need to mark the right numbers. I'm gonna look on the web how to mark numbers in the terminal. Okay, I think I'm going a bit too far in this, but I think that's just gonna be fun, you know. So this that marked numbers, new set. What we're doing here is we want to mark numbers. So these that mark numbers that add the number. Let's do that at the beginning. Because here what we want to do is we want to map each number and check if the number, these that marked numbers, that has n. If it has the number, it means that it is marked, and I have found on the web like a little piece of text to put some, I don't know, yellow code. Let's do that. Let's try that. And here we're going to say n. Otherwise, if this is not marked, we're just going to put n like nothing else. Oh, everything is yellow. I cannot watch. I think yellow is not the right color. Let's just use red. Let's just use red. This is the number that should be put here, I believe. Let's try that. Okay. No, maybe some people might not see red. What's the right? Oh, white. No, everything is white already. I don't know. Let me just choose cyan. Cyan maybe just like. I wish I could. Oh, nice. That's the background color. That's background black. Let's do background white. Picking the colors here. Background white and text black. Is this how it works? Yes, this is how it works. We have our marked numbers. That's great. That's going to be super helpful. You will see that the last step is really marking 13 in the column. So it looks like we've done all this for not much. The next step is to understand there is some problem with the code here, not part 1 but part 2. Oh, actually drone is not the right thing. Hey, here this is not correct. Okay, this piece of code is not correct. So yeah, we did display everything for just understanding that the code is working and the problem isn't in this simulation but outside of the simulation, and this is here. So we're actually gonna update the card here and say unmarked numbers. And basically we just need to go through these.numbers, return these.numbers.filter, we filter a number, and now we have the marked numbers. So basically this was useful what we said. Marked number has n, and we want to make sure this isn't a marked number. So now instead of doing that, we can say unmarked numbers. This is for part 2. Let's actually just reuse this code for part 1 just to make sure this is clean. And I think we should be good now. Last winning card is not defined. Oh yeah, sorry, this is for part 1. Part 1 is just winning card here. So now we have 148. That was the problem. We can go back, take the full input. That's the best part, you know, when you feel that everything is ready. Oh no. I spoke too soon. Multiply. And we get this 9,000. This is it. Thank you so much for the support in this series. It helps a ton. Please continue to give me your like, thumbs up, and subscription. It really keeps me motivated. This is intense, but I'm really enjoying explaining my process to you. So hopefully you enjoy that too. Thank you very much for today, and see you in the next one. Bye bye.